Hey guys, Mr. Marone here. Welcome back in for your second flipped video where we get into a little bit new content here. And I hope that you're getting comfortable with this process, that you're starting to figure out what questions you need to ask, what you still are okay with, and all of that kind of stuff. So as we go through this, continue to make notes on what you could be asking in class and anything that you need from me to make this experience a better learning experience for you. And remember to be taking notes on the guided note sheet that you've been given. You can see that these are also guided notes, just like we had on the previous video. So to start out, we're going to give you a definition of a geometric term that we're going to use frequently throughout the year. And that's the idea of a postulate. A postulate is a statement that we just assume it to be true. We could spend time showing why it's true and all that kind of stuff, but we just say, you know what? It's something that we can agree is true without having to give examples and to really show it or prove it. And one of those really good examples is distance. When we measure distance on a line, when we use a ruler, when we use a tape measure, anything like that, we all can agree on what distance means. So our distance between any 2 points is this keyword here, the absolute value of their difference in their coordinates. Now, when we talk about absolute value, that means that it's distance from zero, meaning it's always going to be positive. And it's important because there's no such thing when you're measuring distance of having a negative distance. So whenever you're dealing with distance, if they're asking for how many kilometers or how many centimeters, you have to have it be positive. There's no such thing as going negative 12 inches. So it's just something to keep in mind that it's always going to be positive. And we get there because of the absolute value. If we look at this ruler that's given here, if we want to know the distance from y to x, it starts at 7 and it works its way back to 3. It didn't go negative 5 units, it just traveled 5 units. It went 1, 2, 3, 4. I'm sorry, not 4 units, not 5. Sorry about that. So it's just an absolute value or a positive value every time we do a measurement. So take a second and try out this first example here. They've given us two questions. They want to know what the distance is of KL on that number line. And then they've given us just a general one where I recommend you try drawing in a number line. Go ahead and take a second and see how you do on those answers. Okay, welcome back in. So as you can see, KL from K to L is from 12 to 16. So 12 minus 16, the distance or the difference between their two values. And that is the absolute value of negative 4, which means we've physically traveled 4 units. Even though it gives us the appearance of having a negative number, we end up with a positive because we can't have a negative distance. Same thing comes for B. Negative 4 minus 11 is going to give us a negative 15. And inside of that absolute value, it turns it positive. So we would have the absolute value of negative 15 or 15. Now, this gets us into giving us some use. We're not always going to deal with numbers, but it gives us the ability to measure segments given a large portion of a line. And we get to this first postulate, the first one that we can agree is true. And it says if A, B, and C are what's called collinear, or that they're on the same line, with B between A and C. So this picture right here gives us a really good example of 3 collinear points. A, B, and C are all on the same line. And it says that if B is between A and C, like it is, then the portion on the left of point B, in other words, from A to B, if we combine that with B to C, it gives us the entire length of the line. So in this example, you've got 5 AB plus 7 BC, and that equals the length of AC, which is 12. Now, keeping that same exact principle, we can actually do some solving with this. So they told us that points F, G, and H are collinear. And they told us that the measure of GH is 16. And they want us to find X and then find the measure of FG. Well, if G to H is this expression 2x plus 2, we can set up 2x plus 2 equals 16, and we can just solve it algebraically. So we have 2x equals 14, and x equals 7 if I subtract 2 there. We found x, and now we have to just find FG. We just have to plug back in. So I have 3 times 7 minus 1, which is going to give me 21 minus 1, or 20. Okay, so we had x equals 7, and then we had FG equaled 20. Go ahead and try example 2. they've given you that JL, this whole length here, is 25. See if you can find both N and KL. Type those answers into your video, and then when you come back, the answers will be up on the screen for you. Okay, coming back in, you'll see that I found that N equaled 4 and that KL equaled 13. And if you notice, it really came from this first setup right here. This is JK, that's 3N, and I added KL, which is 5N minus 7, and that together equals JL, which is this segment addition postulate right there. So just keep that in mind, that you can use that even if you've got algebraic values there and not just numerical values. Okay, now we're going to take this same idea and we're going to apply it to angles. So just like with a ruler measuring segments, we use a tool called a protractor to measure angles. If you've never used a protractor before, you put the vertex of your angle inside the center of the protractor and line up one of the sides so that it sits at 0 degrees. And then you go from that line up to measure the angle. So you'd follow from 0 all the way up 10, 20, 30, 40, 50. If the line came this way, you'd use the 0, 10, 20, 30, 40, 50 on the inside. But either way, you're just counting up. And it's just a ruler used to measure angles. So if they wanted to know measure of angle AEC, we'll start with B. So AEC right here. So I'd start at 0 and I count up all the way up to what appears to be 105 degrees. Okay. And then they asked us to find 2 where we didn't have it at 0. So we're going to have to use that same idea of absolute value. So BEC, it appears that it starts at, let's say, 47 degrees, and it continues all the way up to 105 degrees. So to figure out our angle there, it's the absolute value of 47 minus 105. And that is going to give us the absolute value of negative 58, which is 58 degrees. Go ahead and try example C, where you're trying to find angle BED. Okay, welcome back in. So I found B starting at 47 degrees, and I'm going all the way up to 130 degrees. If I subtract those, I have the absolute value of negative 83, which gives me an 83 degree difference from BE to D. Just like we had with segment addition, angle addition is the same exact thing. If I have an angle, ABC, and there's a ray, BD, in between it, then the pieces of it, ABD, this piece, and this piece here, together create the whole thing. It's a little bit harder to see, but it's the same exact principle. Okay, and if you look on the right-hand side here, this angle ABD is 35 degrees, and CBD is 25 degrees. Well, if we put those together, angle ABC is 60 degrees total. Try to use that same idea for example 1 really quick. So they gave us that ABD, the whole thing, was 103 degrees. If CBD, this piece, was 36, they want this measure. All we have to do is subtract them. 103 minus 36, 67 degrees. So that tells me that angle ABC equals 67 degrees. Go ahead and try example 2. Once again, it's the same thing. We're using this piece plus this piece equals the whole thing. And see what you come up with. Okay, welcome back in. So as you can see, I took angle JNA, 5x plus 7, and I added angle ANB, 2x minus 13, and I set it equal to the whole thing, JNB, which was 14x minus 20, and then solved out from there. And I got 2.8 equals x. This would be a really good time to pause the video if you need any explanation on how this algebra works. And with that said, now's a good time to try the first day practice problems that are in your packet. That's all the information that we have on this video. Feel free to rewatch this to ask any questions that you have in class, and then we will do some practice with this when you get in tomorrow. Have a great day, guys.